Hello, everyone. Very good morning to one and all present here. And dear authors and invited guests, I welcome you to the technical session 2B. My name is Anisha Mishra, and I am the moderator for today's session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2023, Ahmedabad, India. The 7th edition of the conference is being organized in a hybrid mode. The physical event was held in Ahmedabad, India on 27th April 2023, and the virtual event is being held through Zoom today, that is 28th April 2023. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair for the session, Professor Narendra Londe. Professor Narendra Londe is presently working as an associate professor in the Department of Electrical Engineering of National Institute of Raipur, Chhattisgarh, India. He has 14 years of rich experience in academics and research. He has published more than 150 articles in recognized journals, conferences, and books. His main areas of research include medical signal and image processing, biomedical instrumentation, speech signal processing, biometrics, intelligent healthcare, brain-computer interface, artificial intelligence, and pattern recognition. So I welcome you to the session, sir.
Thank you, Anisha. I also welcome all the participants to this session. You can take it further to Anisha.
Okay, sir. So now we'll start with the session, and I would like to invite our first presenter, Purani K, to present her paper on the title Comparative Analysis of Chronic Kidney Disease Prediction Using Supervised Machine Learning Techniques. So, dear presenter, you may please start your paper now.
Am I audible?
Yes, you are audible.
Yeah. A pleasant good morning to one and all present here. This is Purni from Department of Computer Applications, Consulting Academy of Research and Education. Going to present my title in a comparative analysis of chronic kidney disease prediction using supervised machine learning techniques. And my paper area is 63. And these are the contents going to be record, introduction, related works, proposed method, comparative analysis, discussion, conclusion, future work, and references. First, let me introduce my work. So, machine learning technology is currently employed in data analysis and model buildings. Nowadays, healthcare and systems are also evolving in a large amount. So, like this work proposes how we can help with the healthcare systems using machine learning techniques. And a particular disease which I have chosen is chronic kidney disease prediction. Since this disease is a chronic disease, a number of patients affected with this disease is increasing nowadays. So, with the help of this computing technologies, let us predict the disease earlier to avoid to reduce the mortality rate.
I'm not able to see the slide. First slide. Start from the first slide. You're in between of your presentation slides.
Ma'am, is it visible now?
Yes, it's visible, and put it in a slideshow mode.
Yeah. Ma'am, now is it okay?
Yeah, fine.
Yeah, these are the contents going to follow, and this is the introduction. And many people have done this works And they have implemented machine learning technologies into this disease prediction method, and they have implemented this also for drug discovery. And Chen et al. Made their review on machine learning models on this kidney disease prediction, and they have come out well. In Nigeria SK and their studies, they used feature learning techniques like next information gain technologies, and they have employed many supervised machine learning algorithms like ANN, KNN, and also come out with the best evaluation methods. Similarly, M et al. In their studies employed supervised machine learning like techniques on their own kidney data disease set, and they used a randomized tree model and got an accuracy of 97%. In Algeria et al. And they employed machine learning technologies for prediction with the feature selection techniques and came out with a good accuracy. And Ventrella et al. Employed their supervised machine learning techniques and came out with a good accuracy of 97% when they used randomized trees. And this is a proposed workflow I have planned for this. And I'm going to take the data set from our repository and going to pre-process the data and employ a feature selection techniques, and then employ a few supervised machine learning technologies techniques, and then I'm going to evaluate which algorithm is going to best suit with the kidney prediction model. And this is the data set I have taken from our repository. And the parameters include age, blood pressure, and which are the parameters which is suitable for chronic disease prediction. It includes blood glucose, blood urea, creatinine levels, and white blood cells, red blood cells, and other diabetic diseases, hypertension likewise. And this first step involves a data pre-processing. Whatever data we have taken for analysis has to be pre-processed for getting a better accuracy. For this method, I have taken a min-max scaling method for detecting null. First, I have detected the null values and replaced it with the mean method. And then I have taken a scaling technique like min-max scaling techniques. And then further, I have proceeded for feature selection. And this is the proportion of the missing values in our data set, which has been replaced by mean values. And feature selection. For feature selection technique, I have employed information gain, which involves entropy calculation. So this entropy calculation, if we process it with the entropy calculation, the information will be better. And then after process,
Excuse me, you're on the first slide. Why you're not making it full screen and scrolling down your slides? We are not able to see any of your slides. You're now on the first slide only. Make it full screen.
So now could you see it, sir?
Yes, I can see that.
Shall I proceed, sir?
Yes, this is still, I think, not a full screen.
But when I go for full screen, you are saying that.
Yes, please go, please.
Shall I proceed with this, sir?
Yes.
Yeah. Thank you so
Okay,
much,
at
sir.
least scroll that slide. Okay.
Okay, yes. And this is the data set employed and pre-processing techniques. And this is a feature selection method, entropy method, which best suits this kidney disease prediction model. And for further processing, I have split on my data sets into 80-20%, which we do usually. And for employing machine learning algorithms, I have implemented 5 algorithms. At first, logistic regression. So it is a basic and simple supervised algorithm implemented for prediction or classification. Here I have taken a kidney disease dataset and employed logistic regression. In case of linear and logistic regression works better with the use of sigmoid functions. In case of using sigmoid functions, it comes out very well when comparing with the linear regression. So I have taken logistic regression. And the second I have employed is random forest, which employs a number of several decision trees. Random forest is a collection or several decision trees, and at last it employs a voting technique. And likewise, it is finding the average of the decision trees to give the prediction model. So this is the second technique I have employed for the kidney disease prediction model. And third is the Gaussian Navy bias. When coming to Gaussian Navy bias, it employs a Bayes theorem, which gives assumptions regarding the probability of the outcome. It takes all the variables suitable for the target, and it gives us strongest assumptions with the help of probability predictions. And Gaussian also, it follows a Gaussian distribution with the covariance and gives a variable and that gives out the target variable. And Next method I have taken for analysis is support vector machine. It is a by classification method. It also supports the boundary decision boundary results, and then it classifies the data set into target and desist and non-desist. So this algorithm can be employed for regression or classification. And in particular with the SVM, the main thing you have to consider is the consideration of hyperplane, because hyperplane is an optimal plane which separates our data set into desist and non-desist. And at last is the KNN method. So KNN is a very suitable method for supervised class machine learning algorithms. This helps with the for this KNN I have used Euclidean distance Euclidean model for classifying this desist and non-desist. The frequent labels are collected and then it has been classified using Euclidean distance metric. And in terms of after evaluating with all the 5 algorithms and confusion matrix has been got from all the results. So let me say what confusion matrix is. Confusion matrix is used to predict the results of our classification, whether our classification come out well or it may result in a true or false positive rates. There are 4 classifications: true positive, true negative, false negative, and false positives. These are the justifications of that classifications. So depending upon the classification methods, I have evaluated the accuracy of the algorithms. And this is the comparative analysis on the basis of accuracy. Accuracy is nothing but TP plus TN by the total of the predictions, total of all the predictions. On evaluating all the predictive models, Gaussian naive Bayes algorithm gave have better prediction of 98% when comparing with all the 5 algorithms, in specific with chronic kidney disease progression model. This is the comparative analysis short as a result. And as a discussion of this, employing with all the few supervised machine learning algorithms, Gaussian naive Bayes try to be more efficient with this existing algorithms. And this works concludes that Gaussian naive Bayes gives better accuracy when we employ with the feature selection techniques. If we have not employed this feature selection, it turns out to be a little less accurate. This analysis I have done in a working model for next and future work employs of selecting precision model recall methods are being processed at now. And deep learning concepts also works efficient when it comes to analysis. So in future, I'm going to try this in deep learning concepts also. And these are certain references I have for this work. So thank you and queries. Hello.
Okay.
Yes, sir.
Anyone from the audience wants to ask a question? Okay, I have one question to you. What was the formula for accuracy calculation?
TP plus TN by TP plus TN plus FP plus FN.
Okay. So which one is important to you as you are doing the classification, right?
Yes, sir. Yeah.
You would be seeing that the true positive for, say, your deceased and non-deceased data, right?
Yes, sir.
Okay. So in that case, sensitivity, specificity, maybe those parameters are also need to be calculated, isn't it?
Yes, sir. Yes, sir. At present, I have not done, and I'm going through it now, sir. I'm calculating recall precision methods and I'm implementing it in all the algorithms because it differs.
See, when you are calculating the accuracy, you in the denominator of that formula, you're taking all the data, right?
Yes, sir.
False negative, false positive, all right, which is not correct, maybe, because as you want to see only the deceased, whether the deceased cases are how much and what is their presence, then it should be only compared with its related terms. Okay. Okay, that's fine. Means both the things, accuracy is also important. And along with that, you can specifically see that what what is the results for that particular class. That can be seen. Okay.
Yeah, okay,
Nice
sir. I
work.
will consider, sir.
Nice work. Nice work. Okay.
Yeah.
Thank you.
Thank you. Yeah, thank you, sir.
Next presentation, please.
Okay, thank you so much for the presentation.
Thank you, ma'am.
And now I would like to invite our next presenter, Likhit Reddy Kuruvalli, to present his paper on the title Deep Learning Framework for Speaker Verification under Multi-Sensor, Multilingual and Multi-Session Conditions. So dear presenter, you may please start your presentation now.
Hello.
Yes.
Good morning, sir. My name is Likith and my other co-presenter name is Pratham. We are from Kerala Technological University, Karnataka. And here we are to present on deep learning framework of speaker recognition under multi-sensor, multi-session and multilingual conditions. These are the topics for today's discussion: introduction, literature, methodology, results, conclusion, and reference. Introduction. Speaker recognition is a technique of identifying person talking using his voice features and acoustics. How we can do this is based on various signal processing, pattern recognition, machine learning, why to extract the acoustic features. And what are these acoustic features are pitch, formats, and spectral characteristics. It's a very active research area with notable applications such as speaker authentication, forensics, security, speaker diarization, etc. And to further proceed with classification of speaker recognition. Speaker recognition is broadly classified into three types. That is identification. In identification, what we do is we will identify who the speaker is. That's identification. Next is speaker verification. In speaker verification, we will identify is he the speaker whom we are intended to match with. Like it usually does pattern matching kind of things. And speaker diarization. When a multiple speakers are speaking, it's a process of separating and identifying the individuals. This is done to determine which part of the audio corresponds to which speaker who has spoken. And then it goes with text dependent and text independent. Text dependent authentication. This system requires user to speak a specific phrase or series of phrases and then analyze it. And in text independent, the system on the other hand does not require the user to speak specific phrases and set of phrases. Here the speaker can speak some random phrases also. And for evaluation, open set and close set are taken. In open set, some random speakers, like in close set, the system trains on specific speakers, and from the trained people only, the authentication will be done. But in open set, both with open people and the trained people, the authentication will be done. We are focusing on speaker verification. What is speaker verification? Speaker verification is a process of identifying the identity of speaker using their voice. It follows three methods: enrollment, verification, authentication. For enrollment, first we will collect the data, and for verification and store it. In verification, the same person will again speak and it is sent to the model. If it matches, then the score will be above the threshold. If the other speaker are spoken, then the score will be below the threshold. In this way, the speaker verification process goes on. We are saw many literature surveys like speaker-based recognition, where here for classification, for feature extraction, MFCC, IMFCC, etc. are taken. For model purpose, GMM, UBM, IM, iVector, etc. are taken. Here deep learning gives good result. In survey paper, we have learned all the architectures, how they will work, and we have concluded like architecture and feature extraction conclusions. In TIM, in this additive margin signet model, the signet layer softmax is replaced by additive softmax layer. In AM, signet provides better results than traditional signet. This is the conclusion. And speaker recognition raw waveform, the pre-processing is done and raw data waveform is used. CNN model, singlet model, and constant singlet model. 3 types of architectures are trained, and equal error rate of 3.0 to 0.32 is found here. This is the dataset which we have used. This is the standard Indian dataset called IIT GMV multivariability speaker recognition dataset. It is of dual session, and it holds for 100 speakers from the age limit of 20 to 40, and we have stored it in dot waveform. Like, we have huge data and we have classified it according to our requirements. We have classified it into 3 types, where multi-sensor. There were 5 types of sensor, but we have considered H01 and H02 to D01, that is 2 types of sensors. Multilingual. Here the speaker would speak in one Indian English language and his preferred native language, such as Kannada, Hindi, Telugu, etc. And multi-session. Each speaker will speak for 2 times. That is, separate sessions he will speak. Like, we have firstly known about the evolution of speaker recognition. We have come from GMM, UBM, iVector, MF, all these process to deep learning. And in deep learning, we have also done CNN. But there are many drawbacks with CNN, because the CNN use raw wave data form, where high dimensionality inputs are taken. And to handle this, the neural network will face problem. And for sampling, only few samples are trained, then noisy and incongruous band multiplant shape spectrums are allowed, are found. There are vanishing gradient problems also in CNN, and these are machine interpretable. Like, machine can understand what these information are being told, but for the humans, it can't interpret. From here on, my another co-presenter will take on.
So now that we are choosing SyncNet as our model, so how we came up to SyncNet is, we have compared disadvantages of standard CNN, and we have trained our model in SyncNet. SyncNet always performed better. So so to discover more meaningful filters, the first convolution layer in CNN is replaced with a SyncNet. And what it does is, it only lower and higher cutoff frequencies are directly learned from the data. The methodology that is used here is very compact and efficient. As you can see in the slide, there are 3 time domain signals which gives perfect cutoff frequencies in frequency domain. These cutoff frequencies are later passed to the model, where the cutoff frequencies are later re-edited by the backpropagation. So here we convert SyncNet function to filter. So we are replacing finite impulse response to a sync function that you can see, that is g of n comma theta, where the time domain of the SyncNet is given as g of n comma frequency 1 and frequency 2. The frequency 1 is a lower cutoff frequency and frequency 2 is a higher cutoff frequency. So as to ensure that the lower and higher cutoff frequencies are always above the 0, and higher cutoff frequency is always greater than the lower cutoff frequency, we give some thresholds. We give some conditions, and then later we multiply that function with the Hamming window. So Hamming window has features such as high frequency selectivity and smooths out the abrupt discontinuities. However, using many other different windows did not give any significant impact. So this is our whole standard CNN model. So we had 3 convolution layers of kernel 1x3 and 1x5 and 4 fully connected layers. We have trained this with 15 epochs and 128 as our batch size. And we have used Adam optimizers and as a loss function as a default cross entropy function. So in this is a training model of our whole process. So as you can see that the validation accuracy is very near to the training accuracy, which says that this model is not overfit or underfit. And our validation accuracy came up to 66.88%. So here in next slide, we will show you that these are the complete accuracies. See, we have variable parameters and constant parameters. At first instant, we have kept variable parameters language. We have used English language and we have used other native language, and keeping one sensor constant and session 1 as a constant. And then we have also varied sensor, session language, sensor and language. So we have obtained a number of different result metrics. And in this result metrics, we can conclude that SyncNet has always performed better than this. Coming to the conclusion, so SyncNet is nothing but the ideology of using sync function as a kernel in convolution network. Why? Because it has a strong frequency selectivity and it has a it is well suited for the narrowband spectrum. And SyncNet has excellent model properties such as fewer parameters, which leads to faster conversions, and it has an interpretability. And like I showed you in the previous slide, we have very interpretable filters. So that's the reason it has excellent model properties. And overall, SyncNet is a promising because we can bring out a very custom filter banks, and yeah, it produces a very good results. And these are our references, and we are open to questions right now. Thank you.
Likhit and Pratham, it's a nice
Yes, sir.
attempt. I must say that, but the performance received is, I think, very is not that good, right?
Yes,
Yes,
sir.
sir.
And the reason being, we have introduced many variabilities in that, sir.
Yes.
Like, yes.
Yes, I understand that. What I think, when you people are using this SyncNet, whatever that conversion of your signal into the sync function and then putting it, then cutting it off using the Hamming window. Okay.
Yes.
I think that instead of if that as per the standard CN, it is helping you over there. Okay. But I feel that if you are going to find some good features out of that signals, right, the standard CNN will also give you a better performances. Only thing is that the features that you must be acquiring is not good enough. That is why the standard CNN is not giving you the good results, right? I think you should work on that thing.
Sure.
See, whatever the signals are there, they are already carrying the information. If you are converting them, like converting into the sync function and then putting the Hamming window, right? So it is not going to change the information, I think. In fact, it may alter the information or it may reduce the information.
Yeah, it is reducing the information, sir. Like we have used Hamming window, which separates the upper cutoff frequencies and lower cutoff frequencies, and we are only focused on lower cutoff frequencies where the acoustic features are more good to consider.
Right. But instead that, what I feel that if you people using the supervised learning, right, and give the ground truth, take some signals and train your system or train your CNN saying that this is related to this signal, and then you see the performances.
Sure.
I think supervised learning can also help you. Check with that, because because of the supervised learning only, whatever the features that CNN acquires or it develops into the different stages of convolution, they improvises, right? You
Sure,
can try
sir.
with that. Right.
Sure, sir. We'll
We
take
try
your
it.
input and
We
we'll
try
Yes,
to.
just because performances need to be improved further, right?
Sure, sir.
Yeah. Thank you. Nice
Thank you, sir.
presentation. I'm saying this is a good attempt. Right.
Thank you, sir.
Thank you, sir.
Thank you so much.
Next presentation, please.
Thank you so much, Likhit and Pratham, for the presentation. And now we are moving forward to our next presenter. And I would like to invite Shruti Nair to present her paper on the title, Design of an Efficient Deep Learning Model for Identification of Lung Air Capacity in COPD affected patients. So, dear presenter, you may please start your presentation now. Well, I think Shruti is not present in the session. So for now, we will move forward to our next presenter. And I would like to invite Pankaj R. Chandre to present his paper on the title, Explainable AI for Intrusion Prevention, a Review of Techniques and Applications. So you may please start your presentation now.
Good morning, madam. Am I audible?
Yes, you are audible. Please go ahead.
Okay. Okay, ma'am. I am going to share my screen. Ma'am, my screen is visible?
Not yet.
Good morning, sir. Good morning, sir, and all. Myself, Dr. Pankaj Chandra, and I'm going to present explainable AI for intrusion prevention, a review of techniques and applications. So these are the outline of my presentation: introduction, literature survey, system methodology, discussion, conclusion, and last one is references. So I'm going to start with introduction. So with the help of proliferation of digital system and the increasing amount of sensitive data that they handle, intrusion prevention has become a critical area of the concern, and intrusion prevention system plays a vital role in identifying and mitigating security threats, including unauthorized access, malware, and you can consider some denial of services attacks. You know, traditional IPS methods often rely on rigid rule-based approaches that they can be inflexible and difficult to adapt to evolving threats. And now in recent years, the emergence of explainable AI techniques has opened new avenue for developing more accurate and interpretable solution for intrusion prevention. Explainable AI refers to a class of machine learning techniques that produce models with transparent and understandable output. These models enable humans to compensate the decision-making process of the AI system, making them more trustworthy and easier to use. Basically, your explainable AI techniques can be particularly useful in intrusion prevention. Basically, before this explainable AI, we have normal AI, or you can say machine learning or deep learning. So basically, we are interested to apply all these models by using some data sets, and definitely lastly, we will get some outputs in terms of, you can say, confusion matrix, or you can say in terms of accuracy right now. But just consider you got some output and someone is asking you, just tell me you got your accuracy which is equal to 98%. So manually you have to tell each and everything about that process. Yeah, I have used this data set, I have applied that model, I have applied this pre-processing steps, and lastly I got this output. So simply as a user you have to provide all explanation of each and everything. So to overcome this one, we are going to use to explainable AI. With the help of this explainable AI, we will get some output, and at the same time we will get explanation of same output. So definitely no one is going to ask you explanation of that output. Simply your system is going to provide explanation of that output with the help of explainable AI. So with this explainable AI, you can consider any machine learning algorithm, or you can consider any deep learning algorithm right now. But what is the fact of that one? You will get explanation of your output. That is the main thing, main use of this explainable AI. So these are the applications of, you can say, explainable AI. First of all, we can use explainable AI in healthcare. Second one in finance. Third one in autonomous vehicles, customer service, in legal also. So basically in healthcare, your explainable AI is going to help your medical professional to better understanding and interpret complex medical data. And after that, they are going to enable them to make more informed decision about the patient care. In finance also, we are going to use, in finance, your explainable AI can help financial institutions identify and mitigate risk, improve fraud detection, and enhance investment decision. In autonomous vehicles, your explainable AI is going to help to increase the safety and trustworthiness of autonomous vehicles by enabling them to explain their decision to passengers and other drivers on the road. In customer service, your explainable AI is going to improve customer service by providing personalized and transparent recommendations and resolving customer queries for more efficiently. In legal, can assist lawyers in identify relevant case laws and legal precedent, and in preceding legal outcomes. So lastly, we can say your explainable AI can be applied in any domain where transparency and interpretability are important, which provides greater trust, understanding, and accountability in your AI system. So these are the literature surveys. So I have gone through many papers, and I focus on some techniques. Just consider, you can say, lime, sharp, integrated gradients. Then I search on some data set just like NSLKDT, unsupervised NB15, and lastly I consider that one, you can say, evaluation matrix. So definitely for each and every systems you have some advantage as well as disadvantage. On the basis of that one, I have find out some gap analysis. So on the basis of that gap analysis, simply I can say your explainable AI works properly, or you can say works better in the field of intrusion prevention. So these are what my proposed framework. So these are the components. First one, sensor, pre-processing, feature extraction, explainable AI. Basically, in that one, fourth one, I am going to consider my actual model of explainable AI. First three components are generalized one. After that, I am going to detect my intrusion. Then I will generate some alert, and lastly, you will get your response in terms of accept, or you can say reject, or detected, or you can say prevented. So sensor will work to collect data from various sources such as network traffic, system logs, other security sensors. So basically, with the help of that one, we are going to collect some data. So either you can consider real-time data, or you can consider some available data sets. After that, on that data set, we are going to perform some pre-processing. So that pre-processing module pre-process the collected data by performing tasks such as data cleaning, normalization, and feature extractions. After that, we are going to apply feature extraction module. So this module extract relevant feature from pre-processed data using techniques such as you can say PCA, DWT, and other you can say consider any suitable methods. Lastly, we are going to consider explainable AI module. So that one is the important module, or you can say your actual work. So basically, this module incorporates explainable AI techniques such as lime, sharp, or you can say any integrated ingredients to improve interpretable explanation for the decision made by the system. So in this one, you have your choice. Either you can consider lime, or you can say sharp. So that depends on your application, or you can say size of your data set. After that, I have my intrusion detection module. So basically, this module uses machine learning, or you can say deep learning algorithm such as convolutional neural network, or you can say LSTM to identify potential intrusions based on the expected feature. Lastly, we are going to generate alert with the help of this alert generation module. So this module generates alert based on the results of the intrusion detection module, which are then communicated to the response mechanism module. And lastly, we have our response mechanism module. So this module takes appropriate action based on the alert generated by the system, such as blocking the malicious traffic, alerting the security team, or initiating other response. So simply, we are going to collect data set. We are perform some pre-processing on that one. After that, we will apply our module. On the basis of that one, we will get some result. Then on the basis of that one, we will generate some alert. So on the basis of that alert, your admin is going to take some decision. Sometimes you are going to block, sometimes you are going to accept, or you are going to alert your team, right now. So like that one, we are going to consider. So these are the main components of my system methodology. So basically in this one, I'm going to discuss on, you can say, many data sets. So all these data sets are available. So just first one is KDD Cup 99. So size of that data set is given. That consists of 41 features with 23 labels right now. So this data set works proper with this decision tree classifier. Second one, I have NSL KDT. It works better with a random forest. Then I have unsupervised NB15. It works better with naive Bayes. So like that one, you can consider which data set works better with which technique. So just consider you are going to use this ADFA LD. So again, you can say that one works better with your decision tree right now. So just consider you have to, first of all, you have to select your data set, and on the basis of that one, you can apply your XAI, or you can say explainable AI techniques. So again, I have compared all these algorithms with all these data sets right now. So with each and every data set, you will get, you can say, better accuracies. If you are going to consider decision tree and you are interested to apply KDD Cup 1999, so definitely it gives better result. Your random forest also works better with KDD Cup 99. Your NHGB also works better with KDD Cup. Your KNN work better with your KDD Cup right now. So in this one, I am going to discuss. I want to show results of each and every classifier with comparison in terms of, you can say, data set. So on the basis of this one, you are going to select particular one. Lastly, I'm going to conclude, despite the progress made in the field of explainable AI for intrusion prevention, several challenges and limitations remains. For example, the lack of large and diverse data sets can hinder the accuracy and generalizability of intrusion prevention method, Additionally, evaluation metrics for explainable AI are still evolving and more work is needed to develop better approaches for accessing model performance. We believe that explainable AI has the potential to greatly improve intrusion prevention, but there is still much work to be done to fully realize this potential. And in future, researchers should focus on addressing the challenges and limitations of current approaches, as well as exploring new techniques and data sets for intrusion prevention. Ultimately, we believe that the use of explainable AI in intrusion prevention will help to improve the security and resilience of digital systems in the face of evolving evolving threat. In simple words, I want to say use of explainable AI techniques is better option to prevent your intrusion. So definitely you have many more options. So I will suggest just go with your explainable AI. So no need to explain your output. Your system is going to explain your output properly. So these are my references, questions and suggestions. Thank you. I'm done from my side.
Dr. Chandre,
Yes, sir.
I have one question, in fact, one small query. Can you
Okay.
please tell me that Lime and Sharp, both this explainable AI, what is the difference between them?
So, sir, actually, I'm not compatible with that difference. But selection of that, you can say Lime and Sharp is depend on your size of data set.
Have you used both of them for your work?
No, sir. Actually, I have started literature work on that one. Actually, I used, you can say, machine learning and deep learning techniques, and now I just switched to explainable AI, and I want to suggest this explainable AI use better result as compared to your ML and DL.
Okay.
But but definitely, I will start implementation of same. Definitely, I will start, sir.
Sure. Thank you so much. Okay.
Yeah.
Next presentation,
thank you,
please.
sir.
Okay.
Thank you so much for the presentation.
Thank you, ma'am.
Yeah, and now we are moving forward to our next presenter. And I would like to invite M. Pallavi Sudha to present her paper on the title Implementation of AES Algorithm. So dear presenter, you may please start your presentation now.
Hello, everyone. There is a pop-up saying that you cannot present the screen.
Yeah, just try it again now.
Sure.
You can share it. Yeah.
Is it visible?
Yes, it's visible.
Hello, everyone. This is Pallavi Sudha. I am from Electronics and Communication Department from VNR VJIT College. And along with me, my co-authors, Jashwant, Likita are also there. We have done this paper, Implementation of AES, under the guidance of Priyanka ma'am. Let's get into the contents of the paper. Is my screen visible? Can you just confirm me this?
Yes, it's visible. Please go ahead.
Coming to the abstract, securing the information of a user is one of the important aspects in data security. The advanced encryption standard is one of the most popular and commonly used symmetric block cipher algorithms in the world for securing information of the user. This algorithm follows its own way of encrypting and decrypting, where a secure symmetric encryption is used. Until now, there is no evidence that this algorithm is cracked by someone. And that's the reason why this is tough for hackers to crack the logic, which is the reason why it is used worldwide. This algorithm has the ability to deal with different key sizes, such as 128, 192, and 256 bit. And each of these ciphers has 128 bit block size. The simulation and implementation are done using Xilinx software and an FPGA. The system will accept the input and does the encoding, and later the decoding process is defined. And our problem statement is we implemented AES on software to encrypt sensitive data, and the practical implementation also done on Nexus 4 FPGA. The AES done here using byte substitution, shift rows, mix columns, and a round key. our objectives are we encrypt the sensitive data and later generate a round key using plain text and we perform the different rounds like byte substitution on data and and the output that is obtained from it will be later like we shift the rows and then later mixed column would be performed on it. And at last a round key on the data was performed. We will do this up to 10 rounds as it is of 128 bits. At last the program is simulated on Xilinx and dumped into FPGA. We've went through so many papers, and out of all the papers, we found these 3 papers are the recent one, and which help for our research even. And one such paper is optimized architecture of for AES. This paper presents a highly optimized architecture for AES by dividing and merging different sub-operations in AES algorithm. The proposed architecture uses 10 levels of pipelining, but there is a limitation for it. The limitation is clock frequency utilization is more in this paper. And the next paper is advanced encryption standard algorithm for file security. This has employed by large number of organizations for safeguarding files in binary format. It makes sure of a symmetric key to achieve successful data encoding. The limitation is bigger size key increases the degree of unpredictability. It also increases the encryption time. And the next paper is comparison of AES and DES algorithm implemented on Vertex 6 FPGA and microblaze soft core processor. It gives a comparison of both implementation, reveals that the direct Verilog implementation gives a better speed and the area option rather than implementing in a soft core microblazer. And coming to our block diagram, the AES of 128-bit length key comprises of 10 rounds. And there are different rounds in it like sub-bytes. We perform different, process for it before doing it, like sub-bytes, shift rows, mix columns, add round key process are performed for 9 rounds. And in the last round, mix column process is not performed. The AES never uses bits for computation. Instead, it uses bytes. As a result, AES considers a plain text block of 128 to be 16 bytes. For processing as a matrix, these 16 bytes are organized into 4 columns and 4 rows. Secure symmetric encryption algorithm uses 10 rounds for 128-bit keys. These rounds employ various 128-bit round keys that are derived from the initial AES key. The data is first encrypted through the byte substitution. To replace the 16 input bytes, a fixed table is looked up, which is SBox. The input data rows are shifted later. The matrix 4 rows are all moved to the left. Any entries that fall off are replaced on the row's right side by performing circular convolution. Mixed column operation is performed on the resultant data of the previous stage. Basically, a multiplication in the matrix. The major purpose of this step is to diffuse the columns in the AES. The procedure becomes safe as a result of the columns being multiplied by other matrix of a certain kind, which diffuses the location of the bytes in the column. The entire procedure is a matrix multiplication to increase its complexity and potency. After that, the last step, the preceding output is joined with the appropriate round key. In the input array, the 828 bits are organized into 16 bits, which are treated as 128 bits of the data rather than 16 bytes. This procedure is continued until the data has to be encrypted. As I said, the first round, which is the byte substitution, as we've seen here, the box is SBox. We replace we look up the values in the 4x4 matrix and substitute these values in the SBox. And the next step, which is shift rows, we do circular convolution based on the number of the round. Let's say for the round number is 0, and we do nothing. And if it is the first row, we shift by 1. And if it's the second row, we do shift by 2. And the next step is mix columns. We multiply with a specific matrix. So the resultant matrix would be changed. And the last round is add round keys. Resultant output of the previous stage is joined with the corresponding round key, and the process is repeated until end. And and the FPGA implementation comes like this. For the hardware implementation of AES on FPGA, initially Arctic 7 family was used and selected in the Xilinx. To implement the algorithm, code is developed according to the architecture of the FPGA board, based on the number of input and output ports. And a UCF file, which is user constraint file, which is used to interact between the hardware and the software, is written to associate the input and output to the ports present on the board, which can be accessed by the port numbers present on the board. This FPGA board has the ability to display only a maximum of 8 bits, but the expected output of AES algorithm has 128 bits. Hence, what we've done is the UCF file had to be edited simultaneously, associating 8 bits of output to the output ports on FPGA. A bitstream programmable file of .bit extension is dumped into FPGA. Once the chain is initialized on the software board is identified, the .bit file is executed on the board by selecting the program on the board and selecting the previously generated bitstream file stored in the program directory. This is how we've done the FPGA implementation, and this is a RTL schematic of AES. As we've seen, there are 10 rounds which are included in it, and there are different rounds like sub-bytes, shift rows, mix columns, and the last round, add round key. And the result is, the key that we have took is, I think it's visible to you. The plain text is some 5494D4, and the encrypted last one we have got is 132F5 and so on. And at last, we got the same output as we took in the plain text. The decrypted plain text is 54494 something, which is equal to that of plain text. You can see here, which is in the binary form. The data in is this and the key is that. So what we have done is the board that we have took is of limited of only 8 bits. So we manually change the ports in the UCF file. You can see 0 to 7 bits, the output is 00111 and in this the first 7 bits are of same, like which the output over the first 7, I mean the first 8 bits output here is equal to that of here in the FPGA board. This like this we have done for 128 bits on the FPGA board. So our conclusion is that the AES algorithm helps in securing our data from cyber attacks. It is more efficient than RSA algorithm because RSA is less effective in terms of cost factor and management, and it encrypts only less amount of data, and this is a slower process. AES is effective for government and NSA, which is National Security Agency, from cyber security, data protection, computer security. And in the code, we use so many modules. The code reusability is achieved as everything is written in the form of modules. The project was held on V6 platform. This algorithm can also be implemented on lower power devices and on devices with limited output ports. The AES algorithm is also implemented in FPGA kit. And these are some of the references that we have went through. Yeah, thank you for giving me this opportunity, and you can proceed with the doubts. Am I audible?
Yes, Pallavi, you are audible. Thank you, Pallavi.
Yes,
Pallavi,
sir.
I have one doubt here. As your FPGA is able to show you only the 8-bit output,
Yes, sir. Yes, sir.
right?
Yes, sir.
How is it possible for your FPGA board to process that 128-bit key, cipher key and everything inside the processor?
Sir, I think for that advanced technology, I mean, a FPGA board, which consists of so many output ports should be used. We have only up to 8 bits. I mean, the limitation of the FPGA board right now, what we used is of 8 bits. So what we have done is,
that is what I'm saying. If your cipher key is of only 8 bits, right? Will it
yes,
be
sir.
having any code inside it?
Will it having
any code? Say that, why do you use key, cipher key? Why do you use it?
cipher key because in order to nowadays, as we say, everything is through internet. So we transfer data from
Yeah.
the sender to
Isn't it?
receiver.
So
Yeah.
its length should be good enough.
Yeah,
And if
yeah,
I'm
it's
talking about 8 bits only, the length of the, what will be the length of the cipher key?
sir, here the cipher key length is 128 bits, but what happened, the output is also 128 bits. But right now, our FPGA board is of the limitation, I mean, it can only show up to 8 bits output.
Okay,
Like,
show only 8 bits output.
it can only show 8 bits. So what we have done in order to verify whether the output that we have got is right or not, we manually change the ports in the UCF file. So what we have got, the output over here, as you can see, the output which is over here, we manually edited the ports in the UCF file. So,
but with the help of the ports, you are able to access all the 128 bits.
Yeah, exactly, sir. Exactly.
Right.
That we have achieved.
That's thank you, Pallavi. Good.
Thank you, sir. Thank you so much, sir.
Next presentation, please.
Thank you so much, Pallavi, for the presentation. And now moving forward to our next presenter, I would like to invite Siddhant Thapliyal to present his paper on the title IoT-based collision avoidance system with the case study using IR sensor for vehicles. So dear presenter, you may please start your presentation now.
Good morning, ma'am. Am I audible?
Yes, you're audible.
Okay, ma'am, let me share my screen.
Manasvi, are you presenting on behalf of Siddhant?
Yes, ma'am, I'm presenting on behalf of Mr. Siddhant Satyalthar.
So you're one of the co-author, right?
Yes, ma'am.
Okay, fine.
Good morning, sir, and all my teammates present here. My name is Manasvi, and I'm currently pursuing BTech from Graphic Era deemed to be University Dehradun. And I'm presenting my paper ID 122 on behalf of Mr. Siddhant Thapliyal, sir. He is a lecturer in Graphic Era deemed to be University. And my title for today is IoT-based collision avoidance system with the case study using IR sensor for vehicles. These are my co-presenters. So let's start with it. We have contributed in this paper. These are the following contributions. We have discussed the motive, the need of the collision avoidance system in vehicles, and further, we have provided the details of the methodology of the collision avoidance car with Arduino. We have studied and developed an intelligence and autonomous obstacle avoidance robotic vehicle using the Arduino. And finally, our work is finished with some concluding videos, photos, and some future works too. These are the overview which we are going to discuss in this presentation, namely introduction, types of collision avoidance system, need of collision avoidance system for vehicles, key literature review, block diagram of collision avoidance car using Arduino, main components of collision avoidance car, result and discussion, conclusion and future work, and some references. So let's start with the introduction part. So what is a collision avoidance system, or what does it consist of? It consists of the four main elements. These are number one, the IoT-based advanced driver assistance system, which will be used to guide a driver to avoid him from any collision or from any accidents. As we all know that the number of accidents are increasing day by day. So to avoid that, I have used this IoT-based collision avoidance system. And number two is servo motor, which is used to rotate the gears at certain angles, and maximum it can rotate to about 180 degrees. Thirdly, we have used the Arduino Uno controller. It is a microcontroller board which is based on the Atmega 328 processor. We have used the GPS sensors and range of technology too. Coming on to the types of the collision avoidance system, there are four types of collision avoidance system. Number one, automatic braking system. As the name suggests that the braking system will be applied automatically whenever some obstacle will be arises in front of the car. So it is an active safety system in cars that automatically senses the obstacle and thereby applies, or we can say that it increases the braking force to avoid the collision. Secondly, we have the adaptive cruise control. It is a system designed to help the road vehicles to maintain a safety following distance and stay within the speed limit, as we have seen that there are many rush driving nowadays. So to avoid that and to keep the vehicles to be stay in within the speed limit, we have used there is adaptive cruise control also. Thirdly, we have electronic stability control. It helps to prevent the vehicles from skidding. During raining seasons, we have seen many vehicles to skid. So to avoid that, there is electronic stability control system too. Fourthly, we have the park assist. It is an automatic parking guide system that helps the drivers to park with a greater precision. Now, furthermore, we are coming to the need of collision avoidance system for the vehicles. There is a great need of collision avoidance system for the vehicles, as we know that the number of deaths due to accidents are increasing day by day. Therefore, to reduce this graph, there is an urgent need of collision avoidance system for vehicles. We need the collision avoidance of vehicles to cut the fatal and injury crashes, to prevent up to a very high proportion of rear end collisions, to reduce the accidents, to assist drivers to avoid rear end collisions, to provide the drivers with enough time to avoid the accidents, providing a more safer side. These all points ultimately goes to the remark that the collision avoidance system is very necessary for any vehicle to avoid the collision. Now, moving on to the key literature reviews, Philip proposed that a proper strategy for detecting and avoiding vehicle collision is crucial. Lee presented that the path planning and tracking system of an autonomous vehicle is designed to avoid the collision on slick surfaces. Hamidi presented that one of the services on the Internet of Ships that is envisioned is cooperative collision avoidance amongst inland waterway ships. Now, let me show you block diagram of collision avoidance car using Arduino. We are here with sensor, Arduino, motor driver, which is used to control all the four gears, namely G1, G2, G3, and G4, and one battery. This is the main components we can say of a collision avoidance car. We will be studying car, Arduino Uno, ultrasonic sensor, Arduino Uno. Here it is. It is a prototype board based on Atmega 3280 microcontroller, and it can work with a variety of sensors and actuators. It is mainly used to manage all the operations, and it assigns tasks to each device. We can say that it is the brain of the um, obstacle avoidance car. Now we have secondly ultrasonic sensors. It is a non-contact distance measuring technology, and its range is, it can measure the distances from the range of 2 centimeter to 4 meter, and it is used to identify the obstacle and is used on the top of the obstacle avoidance car, so that it can measure the distance and can identify the obstacle in front of it. Now we have the motor driver. It supplies bidirectional current to all the four motors which were there on the block diagram, namely G1, G2, G3, G4, and it controls the left, right, forward, and reverse direction movement of the car. Now we have the circuit diagram of collision avoidance car using Arduino. Here it is. This was the obstacle avoidance car which I have made, and I have used ultrasonic sensors over here and to calculate the distance to be and to measure the distance and identify the obstacle in front of it. I have used Arduino Uno over there and motor gears, and all the 4 gears are besides the 4 tires of this car to control its movement. This is the result and discussion. Autonomous we are saying that it is automatically, it can detect the obstacle in front of it and can accordingly it can maintain the distance, and whenever it finds that there is no obstacle and can move in that direction. And it is an intelligent collision avoidance car using Arduino, and it detects the obstructions in its way using the ultrasonic sensors while going ahead, and it adjusts its direction of motion by watching its left or right direction using the servo motor, as I have said. Here is one video of this car. Let me show you that. As you all can see that when the obstacle comes in between its path, the motor turns around to check the path, and then it moves and continue its motion. This is the conclusion and the future work. With the advancement in robotics, it can be modified and it can be used in cars to avoid the accidents. It can be used in household works too, such as automatic vacuum cleaner, automatic lawn mower, etc. It can be used in mines and factories to uplift any heavy component. These are some references which I went through, and thank you. That's it from my side. Any queries, please?
Yes, that is some work good attempt, I must say, because collision avoidance is very important as we are moving towards the automation of the cars.
Yes,
Right.
sir.
What I feel that there are some methods from the deep learning, right?
Yes, sir.
Which have been already reported in the literature to provide this
Yes,
similar
sir.
car this
Avoidance system.
right avoidances, right?
Yes, yes,
So
sir.
did you compare your work with their studies, or
So I haven't compared my work with that till now, but in future I'm trying to compare this work with, and furthermore I'm trying to add uh, many features to this, such as voice controlling, and by adding some arms over there to pick up something. So all these work I'm planning to do in the future.
okay,
Yes,
okay,
sir.
that's okay.
Yes,
Thank
sir.
you. Thank you so much.
Thank you.
Next paper,
Thank
please.
Thank you, Manasvi, for the presentation. Moving forward to our next presenter, I would like to invite Mohammad Motahar Hussain to present his paper on the title Modeling the Impact of Access to Finance on MSME's Contribution Towards Exports of the Economy. Dear presenter, you may please start your presentation now. I think he is not present in the session. So for now, we'll move forward to our next presenter. And I would like to invite Sneha Chiniwar to present her paper on the title Online Hate Speech Identification Using Fine-Tuned LBOT.
So good morning, everyone. I'm Sneha Chiniwar. Today I'm going to present my paper titled Online Hate Speech Identification Using Fine-Tuned Albert. I'm a research scholar at University Visvesvaraya College of Engineering, Bengaluru. This will be the flow of my presentation. Coming to the introduction, social media, as we know, it is one of the most innovative innovations of the 21st century. As people say, everything comes with its baggage of its own pros and cons. Despite social media being extensively popular, great platform for marketing and a great platform to reach any person living in any part of the world, it has its own, it comes with its own baggage of negativity. And one such negativity is spreading of hate speech. Hate speech is nothing but a kind of speech or gesture or a display of behavior that can stir up the violence or intolerance against an individual or a group of people among in a society. When this is performed online, it is called as online hate speech. With the popularity, as the popularity get increased of social media, the spreading of online hate speech has also increased exponentially. So in this work, we are trying to address this problem by fine-tuning a transformer-based language model called Albert to recognize this effectively and create a hate-free online environment. So coming to the related works, with the evolution of research in natural language processing, many people are experimenting with different models to and try to combat the online hate speech. In one such work, Siri tried to implement an use optimization algorithm called Seagull and try to identify and classify this hate speech that are present in online social media networks. Even though the results were promising, but the data set that they've used were very small, so they failed to generalize. The results were failed to generalize. In other work, Bahadur tried to develop an intensity scale, which is of kind of color coding, and they tried to manually label each and every site based on the intensity level of hate speech that is present in that site. Here, the focus is mainly based is to try to understand the dynamics of hate speech and how this escalates from just being a mere offensive comments online to actually actually a harm in the physical world. The stress is more on the understanding that dynamics rather than designing a model that could able to combat these online hate speech. In another work, Mr. Khan actually tried to combine the models of bidirectional LSTM and deep convolution neural networks and try to address the problem of online hate speech. Even though the results were showed satisfactory performance, but when we analyzed it deeply, we could able to understand that the contextual understanding of the text was not up to the mark. The same happens with the Williams work, where he has used a classic combination of embedding technique and machine learning algorithms. And even though the results were again good here, but the contextual understanding of the text is what the drawback here. The models were not able to understand the context of the text properly and able to classify it. So in order to understand the context of the text, it is very much important to go one step ahead and try to use transformer-based model, which is the core of the Albert model that has been used in our work. So these are the few recent literature work that has worked on the same line of understanding and identifying the online hate speech. Coming to the methodology, we have used a data set which consists of 5,125 tweets, out of which 70% of them has been used for training, 20% for testing, and 10% for the validation task. This data set is given to the Albert model. As I say, Albert is a very light version of BERT model, which is a well-known transformer-based language model. Its acronym stands like this, like bidirectional encoder representation for transformers. It is popularly known as BERT. And this Albert is a lighter version of BERT. And this Albert internally consists of several components such as input tokens, embedding layer, 12 transformers layer, pooling layer, classifier layer. So when the dataset is first given to Albert model, it will be just converted into tokens using sentence piece tokenizer. The data will be converted to tokens, and the output of these input tokens are given to the embedding layers, where the tokens will be mapped to high dimensional vectors. And then the output of these embedding layers are given to transformer layers, which internally again consists of two layers. One is the multi-headed self-attention layer, and the one is the feed-forward neural network layer. So this multi-headed self-attention layer converts these embeddings into more precise embedding by every token will be converted into embedding by looking at the tokens that are there in the sequence. So it has more contextual understanding. It is generating the representation of a token by seeing other tokens that are in the sequence. This happens like 8 times, and all these are concatenated and then they are forwarded to the feed forward neural network, which is nothing but a single neural network layer. So finally, the output of these transformer layer is a representation of the tokens that are generated by seeing the tokens that are there in the sequence. So it has better contextual understanding of the entire text. And then the output of this will be given to pooling layer in order to aggregate these representations into a fixed size vectors, and then again to the classifier layer. So basically, this is the architecture of Albert. So what we have done is we have used the Albert architecture. We have used the pre-trained Albert and fine-tuned them for our particular task of identifying hate speech on this particular data set. So we fine-tuned this model by varying. We experimented with different hyperparameters, as Albert consists of 31 million parameters. We only added a final classifier layer and experimented with different hyperparameters. And the major parameters that actually made effort and gave better results were as shown, and the selected values for the same are also mentioned here. So basically, we took an already pre-trained fine-tuned model so that the hardware requirement from our side gets limited and training time also is less. So we already took that pre-trained model, we trained it for this particular task on this particular data set, and by varying these hyperparameters. This is the entire methodology of our work. So finally, we got these evaluation results for training and validation and testing part. And the second table is showing is that the data set that we got is from our standard IEEE transaction paper, where they have used different combinations of embedding, machine learning, and deep learning algorithms, and they got these results. So when we used even the randomly selected 50% of the data set, and we trained this using the fine-tuned transformer models, we could able to beat them with, even though with the limited data set. So this is what the result is. And these are the graphs that specifies the evaluation metrics of the training data. So we can clearly see how the precision is actually reaching its absolute value 1 during the training phase, and the rest of the results are also good. Actually, we can see it also reaches 0.95. Almost everyone reaches more than 0.95 during the training phase. These are the evaluation metrics during the for the training data. Whereas this is the evaluation metric graph for the validation data. The ups and downs of the curve that we can clearly see here clearly specifies that the data set is not completely overfitting to the training data. All these variations clearly show the model is learning, and it is keep on improving as it exposed to more number of batches of data. And this is the data set loss of both training and validation data. As we can see in the training data, the loss gradually comes to almost 0 as it exposed to more and more of data. And the variations here in the validation graph clearly shows that the model was still learning when it was exposed to limited amount of data. As it exposed to more and more, the slope kind of becomes smooth. So this is about training and validation datasets loss graph. And coming to the conclusion and future directions of this work, as we know, social media is a very famous tool now. We just need to have an access to the internet. We can have access to social media easily. That is one of the reasons why it is so prone that can be used to perform spread hate, show offensive behavior, and many more offensive activities can be done using social media. So in order to combat these spreading of online hate speech, we used a pre-trained model and tried to address the problem of online hate speech. This is just a first step in identifying to combat the problem of online offensive behavior. This can be further improved with many other transformer models available and are keep on evolving every day. We get to see more and more number of transformer-based language models today. So we can experiment with the most advanced transformer models and try to fine tune. And the day is not far that we can able to really develop a social media network that could able to completely avoid all these offensive behavior in real time. So these are the references that I have gone through to perform this presentation, and thank you.
Thank you, Sneha. It's really nice work. You have done quite a good experiments, done the comparison, calculation of the performance parameters are very well done in this particular work.
Thank you, sir.
Understanding the textual understanding of any social platform,
yeah,
right,
it's kind of
has
tough.
challenges of challenges of writing there, right? What people write, they use some sort of
yeah,
I must
they
say
don't mean
that
the same.
it is not, it is a new language that they are using, right?
Yeah, every
They
day
are
that
having,
language is changing.
yes, their symbols are changing, they are using some short words and everything. How do you find to face these challenges?
The only way is we have to keep on training the models with everyday data that comes in. That's the only possible way it is there. We have to, while using also like the chat GPT we have, it has to perform its duty. Along with it, it keeps on getting trained. That's how we should develop a model. I mean, we should, in future, we should be thinking in that way.
That is what I feel sometimes difficult, because see, there is such a huge population which is using the social media platforms, watching everyone that what kind of words they are using, and if something is different there, then we have to give it to our model for the training. Okay. Which is something means we need a system which is actually looking into all the text being used on the social platforms, which is a huge one. Which is itself a huge task, right? Chat GPT is somewhere, I don't know how it is going to help, but it searches the data from the social platforms and it gives you the answer.
As of now, yes, it is only doing that. It is being trained.
Yes,
and based
but
on the
it is
training,
not. But it is not able to tell you that what words they are using. What?
No. I just gave you an example that along with the job that is doing, it has to constantly train itself for the new data.
Right. That is what that challenge is there, of course. Right?
Yeah, and the hardware requirement is really huge. We can't.
Yes. Thank you so much. And you can, I think you can submit the extended work to some journal also. This really looks fine, right?
Yes, sir. That's the plan actually. I'm working on my journal already.
Okay. Thank you so much.
Thank
Next
you,
presentation, please.
Thank you for the presentation. And now we are moving forward to our next presenter, and I would like to invite Zalak Thakrar to present his paper on the title Predicting Phishing Effort, Data Collection for Machine Learning Model Using Scientific and Indigenous Method. So dear presenter, you may please start your presentation now.
Hello, am I audible, ma'am?
Yes, you are audible.
Okay, I'll share my slide. Yes, is it visible, ma'am?
Yes, it's visible.
Okay, am I audible?
Yes,
hello.
Please go ahead.
Okay. Good afternoon, sir, and good afternoon to all the participants of the conference. Myself, Jalak Takrar, PhD scholar from the Savrasya University. My topic is basically regarding the fishermen and the coastal area, and the outline of my paper is defined here: abstract introduction, method, dataset, data pre-processing, and the conclusion. Let's start with the abstract of the paper. In abstract, we can say that the Gujarat has one of the largest sea coastal area, and in Gujarat we find such kind of problems to the fishermen. That specifically when the fishermen go for the fish catching into the sea, there may be a possibility that they cannot be able to get the such kind of amount of fish from the sea, So on the basis of that, there are some kind of reasons that the fish cannot be available, or so the fishermen can consume so much time, or make such kind of expenses which cannot be get the proper relevant output for them. So on the basis of that, we create such kind of model for them, that it will predict for the fishermen that the particular location at where the fish can be available, and the fishermen can easily get the location of the fish, and they can able to reach that particular location and finding the fish. So this is the actual work what we have to done for the particular research. So as per our research, we find that the right now many of the fishermen can use the traditional technique of the fishing, that they can use the boat and go to the sea and catch the fish. But sometimes what happen, they go further and further and cannot able to search the proper location at where the fish is available. So sometimes they can not able to get any kind of relevant fish from the sea. So that is the traditional technique of the fishing. Right now in these days, the scientific methods are also implemented for catching the fish, in which we can use the SST and chlorophyll. These two are the parameters of a scientific method. On the basis of, we can able to say or predict that particular place where the fish is available. So on the basis of sea surface temperature, that means the temperature is one of the most important criteria at which the fish is available, and on the basis of that we can predict that particular location has contained the fish. So we can alert the fishermen that this place can conduct many fish, and you can able to reach that particular location and get the fish. So what we done in this paper, we try to combine the two methods, which is traditional and scientific method, and create our own method, that is indigenous method for the fishing. We can use both the technique. We use the traditional as well as scientific method for catching the fish. uh, Let me go to the introduction area. In the introduction, we have the researcher belong from the Porbandar coastal area, and we saw the area in from the northern and eastern coastal area for the Gujarat. So this is one of the largest area which have the Gujarat has for the sea coasting and catching the fish. So with the use of indigenous technique, we first of all have to create a data set or correct the data set for particular model creation. So we create two kind of data set in it, and use the such kind of things which has been covered as per the following: last 10 years of data set from the satellite, use the fisherman indigenous technique of the data set, and also use the machine learning techniques and prediction of the output with the use of random forest technique. So SVM technique, linear regression technique. On the basis of that, we can able to get the prediction for the SST and chlorophyll, and get the proper prediction for the fish availability. So we can increase the CPUE, that is catch per unit effort. We can increase that particular CPUE for the fishermen and get more effective. We made the fishing and make work easy for the fishermen. So we are moving on to the methods which has been used. First of all, we have variety of the data. The researcher try to get the data using primary and secondary data collection, and to analysis that particular data, the researcher use the Azure machine learning for analyzing the particular data, and make the proper data set, cleansing the data set, and analyze the particular data. The researcher use the Azure machine learning cloud services. Next, as per the primary data set, the researcher create one questionnaire and give it to the each and every fisherman, that what did they think, at which place they can able to go and fetch the particular fish, and what are the parameters that they have to follow for catching the fish, and on the basis of that we can able to get that the height, weight, temperature, volume, and other more qualities. On the basis of that, the fishermen in the traditional technique use and reach the particular location and fetch the fishes. So with the questionnaire, researcher found this type of parameters for the fishing catch the fish from the particular location. So on the basis of that, the primary data has been collected. These are the parameters for the primary data set, which has been explained by me. Next thing, when we move to the scientific method, the researchers found the data from the satellite ocean color website, and on the basis of that, the researcher can get the following things and the following patterns for the particular fish catching. We can find the sensor, then after we can find the month in which the fish can be catching, fishing season. It will also specifying the time, afternoon and morning, which time is the appropriate for catching the fish, sea surface temperature and chlorophyll specification. These all things has been defined into the particular secondary data set, which has been taken by the researcher from the ocean color website. So in this way, user can able to create the secondary data set. After getting the secondary data set, the researcher try to apply the particular both the technique, traditional as well as scientific, and design its own a method that is known as an indigenous technique. With the use of indigenous technique, we can able to give the better performance to the fishermen, and that is the conclusion of the model, that fishermen can able to get the proper location for the fishing, as well as we can also save the time for the fishermen, and also get the relevant costing reduces for the catching the fish, so that we can able to use the particular scientific technique. So as per our research, the fishermen can easily fetch or catch the fish from the particular location using the different parameters like SST and chlorophyll. So this is from the my side. Yes, any question?
Fish availability based on some parameters. Can you please define any one of that parameter?
Yes, sir. Here it is the sea surface temperature. It is what scientific method is saying, sir. Sometimes the sea has containing the different temperature at the different level. Suppose if we are in the top, it contains the different temperature of a sea. Suppose we are deep into the water, going deep into the water, it contains a different sea surface temperature. So there is such kind of temperature at which the fish can be contains more, or the fish are chances to catching a fish more. So from the satellite, from these website, we can able to get that particular SST value, and on the base of we can get the prediction that this temperature is a better for the fishes. So we can suggest, or we can give the recommendation to the particular fisherman that you can able to reach that particular location and get the
such sensors are already available. You are saying here that ocean color website.
Yes, it will it is
Terra sensor.
Yes, it is just a parameter of SST. It will not predict the particular fish availability. It will not predict the fish availability. It just give the sea surface temperature. We have to find out at which temperature the fish can be catch more.
Yes.
It will just
it will give you about the values of those factors. Not exact. It will not precisely tell you that whether the fish is available.
Yes,
It's up to our experience that we have to set the values of these factors so that so that we can say confirmly say that whether the fishes are available or not.
Yes, sir. Yes, sir. Yes,
okay,
sir.
Thank you. Thank you so much.
Okay, sir.
Next presenter, please.
Yeah, thank you for the presentation. And moving forward to our next presenter, I would like to invite Yashwant S. Ingle to present his paper on the title Skin Cancer Recognition Using CNN, VGG16 and VGG19.
Thank you, madam. I'm getting a message. Hello, madam.
Yes.
I'm getting a message. We cannot start screen share.
Can you please try again?
Yes, ma'am. Is the screen visible, madam?
Yes, it's visible.
Okay. So, good afternoon, all. So, I am happily presenting paper ID 81. So, my topic is skin cancer recognition using CNN, VGG16 and VGG19 architectures. My name is Mr. Yashwant Sudhakar Ingle and my PhD research guide Dr. Nizat Sheikh Madam. Agenda for today's discussion is I will introduce to the topic, then we will discuss motivation, aims and objective of this research, methodology I adopted for doing this research, programming and data science involved, and as this is my PhD research, I will also like to just say some words on progress 1, 2, 3, 4, my progress 1, 2, 3, 4, and discuss that. Then I will discuss my publications and some achievements related to this research. So we know that skin cancer is very important to be detected in its early stages, and natural accuracy of doctor is only 60% to diagnose the skin cancer. So it is very likely to use AI to facilitate doctors for early detection of skin cancer. So this project is motivated to save the lives suffering from skin cancer, and when the patients are unaware specifically about they have cancer. So the PhD students from Stanford University had undertook this research project, and they got 65% accuracy using the CNN model or architectures to classify the skin cancer in those days. So now the models are improved, so I thought it's a good idea to go ahead and continue in the same research domain. Now, what I did, I tried the training models or pre-trained models I used, and I trained them on small data, also on big data, and I experimented. So I found that CNN performs better for this purpose, and I also did courses from Stanford University and achieved good grades in line with the in this research in ML and DL domain. So motivation is really to save the life of suffering people and help them get their skin cancer detected early stages. So aim and objectives are like very simple objectives and aims I get to understand various types of cancer and how to diagnose. Also, to investigate AI methods that are helpful to diagnose the skin cancer, to have AI model and do the training of them and test AI models and improve the accuracy. So for this, I did a cutting edge research and I really work hard. And objectives fulfilled. All these four objectives are fulfilled so far, but partially fourth objective is still in line. So I'm working on that. AI model will be done. This objective is learning methods selectively. Yes, I selected the learning methods and applied. Training and testing of AI models will be done. So I did that. And investigation of better technique is still in line because I'm still doing research on that. Methodology so far I use is supervised learning. I haven't gone for any other type of learning because CNN falls in supervised learning category and it is suited for object detection or object recognition part. So moreover, it's a pattern recognition kind of thing and classifying the images into cancerous and non-cancerous classes. So CNN works well for this purpose. I use Python and TensorFlow. Also from Kaggle, I took small data set initially, and now I got 30K samples in data set with math classes. So I use that as I'm calling it as large data set. My research contributions are I investigated the effect of various models on same data, investigated improvement in the result by segmenting the data, So my one paper got published on image segmentation. If images are not segmented, I will segment them using CNN and then pass it to the further classification. Then I did models using CNN LG 16 and 19, trained and tested on segmented data of small and large size both. Work on data augmentation is still in progress, and I partially did that, but I feel scared to go for augmentation because it's very serious project of cancer. So augmentation I'm a little bit worried about. Investigated which models will be useful for skin cancer detection. So I found CNN and its CNN architectures are good for this purpose. Then this is basically a CNN model. Quickly we will see that so many convolutions layer followed by pooling layer. So what is convolution layer? It applies filter on the input image and it find out the feature and build a feature map. Feature map is of very huge size, so we don't want that all the features to go ahead and participate in prediction. So we selectively pull the features using max pooling or any pooling technique and pass on the selected features ahead. Again, we have convolution and pooling there. So after the last convolution and pooling, we flatten. There is a flatten layer. So we flatten the output of pooling layer, last pooling layer, and pass it to the dense layer. And dense layer is the classification. Here the connections are weighted, and finally it is connected. For last dense layer is connected to the output layer. So you can see here one figure is 2, and we are having here 0 to 9 is 10 output layer for classification of digits. ICTIS architecture I found is superior to previous architectures, and I selected that and I experimented and verified it also. So it has, you can see here that 444. I'm Yashwant Tingle, madam.
Yeah.
Hello, madam.
He's
Yashwant Tingle here. My presentation was not over. It got disconnected in between.
Yes, Mr. Ingle, please continue. You please share your screen and continue.
Yes, madam. Yes, sir. Thank you. Is the screen visible, sir?
Yes, it's visible.
Thank you, madam. So, architecture of CNN I was discussing. This is the digital antenna architecture, which is very good, and it has a way to pass image by reshaping the image to 24 by 24 RGB image. So it has a shape of 224 to 24 by 3. So 3 channels are there because it's RGB. So 3 channels. So it has filters. So as you can see here, 64, 128, 256, 256. So these are the number of filters present in each convolution layer. Maximum number of filters here are 512. So with this, the very good inspection of the image happens, making use of CNN architecture. So we have pooling layer where we do max pooling, and the we can say stride is of 1. So very minutely we move the window on the image and inspect the image. There is a relay there. So this, if the positives are to be passed on, the output will be 1. If the negatives are there, output will be 0. So this is really helpful to reduce the burden on the data. And last output layer is having 1000 neurons, saying 1000 categories we can classify the images making use of CNN. This is a 16 is previous version of disease and antigen. So it has similar kind of architecture. So data set I use is ICTIS 2019 data set, and I divided into 80% data going for training and 20% going for testing. So there are 8 classes images here. So I'm not much good in medical language, so I will call 8 classes of cancer are here, and 1 class is of non-cancerous. I have these results. CNN results, you can see that the training accuracy is good, but the testing accuracy is not that good. Loss is also getting stable in our screening, and it's not good. It's very high loss during testing. So there, VG16 results are also. You can see that they are not worth it, but training accuracy is again good and testing accuracy is not that good. But VG19 case, I got this. You can see this table where I have put the accuracy and loss for all the models. CNN 75% accuracy and loss is 62% for training, and testing accuracy was 58% and loss was 1. So here which is 16, 86%, VG19 also there 86% training accuracy, and loss was same 34.7 to 34.7, similar, because same data set I was using, so they were similar kind of results for training. But change was happened in testing. So I got very high accuracy by VG19. So 75%, and it was earlier by VG16 was 50%, and CNN were 58% accuracy. So loss is also less for VG19 architecture. So with these results, I can conclude that VG19 for better performance, and these are the collage of my coding and how I obtained result. Now in my progress 1, so I put 2 papers in Scopus and both got published. Scopus Index journal was IGHS. Progress review 2, the segmentation paper got published in same journal IGHS, which was Scopus Index. Progress 3. So I started working on NVIDIA system because it was saving my training time, and the data set size was increased to 30K. So after that, in progress 4, I'm still continuing on NVIDIA and I'm asked to improve on quality publications. So this is a good opportunity for me to present here. And I published 1 book and 2 scopus and 1 scopus, so 3 scopus so far, and this is my 4th paper on this research. Certifications and some achievements are mentioned on this slide. If you want to go through, so
Thank you. This is
thank you, sir. Thank you, sir. Questions? I'm open for questions.
Yes, I am also doing research on psoriasis skin disease for a long time. Okay, so I have one very simple question to you. When you have moved from VGG16 to 19,
Yes,
what
sir.
was the reason? What was the reason that you have moved from 16 to 19? Why do you feel
So,
that you need to increase the number of layers into the VGG16?
yes, sir. So if I could have stuck into VG16, I might have achieved the better result. But as the both models were readily available, so it was easy for me to just change the code instead of taking VG19. 16, I put 19 and experimented using similar kind of code. So that is the basic reason. Nothing technical, but if
Mr. Ingray, you have to just
yes,
understand one thing. Whenever
yes,
you
sir.
increase the number of convolutional layers, the computational burden on your machine is going to increase.
Yes,
You
sir.
have to justify your selection of number of layers. If
Yes, sir.
19 are required, then it is okay. If the 19 are not required, then you should not keep it 19. It is not necessary that as VGG has, that group has decided 16 layers, it means that it doesn't mean that we always have to use 16 layers. It is up to our application, where it may be possible that we could achieve the result maybe 5 layers also, or maybe with the 19 or 20 layers also. So you have to see into that, right?
Yes,
So
sir.
that will
So
reduce your.
now, yes, sir. Now the data set I am planning for 1 lakh, so I am going for VGG19, thinking that it will, as it is giving better performance. So the layers will be required, and I have high-end system to save the computation time. NVIDIA's system is with me.
Right. Okay. Thank you, Mr. Ingray.
Thank you, sir.
Next presenter, please.
Yeah, actually, there is one more presenter who's left. So I would just quickly introduce him. Yeah, Mohammad Motahar Hussain to present his paper on the title Modeling the Impact of Access to Finance on MSME's Contribution Towards Exports of the Economy.
Okay.
So dear presenter, you may please start your paper now.
Okay, thank you. Thank you for giving me the opportunity. I'm sharing the PPT. So, as you can see in the screen, my topic is modeling the impact of access to finance on MSME's contribution towards export of the economy. Before starting the presentation, I want to say something about myself. That is me, Mohammad Motahar Hussain, research scholar, University School of Business, Chandigarh University. Actually, I am from Bangladesh. I am pursuing my PhD in management. Let me start my presentation outline: introduction, objectives, methodology, regression model, trends of export contribution, interpretation of the regression result, and conclusion and recommendation, and scope for the further future research. These are the presentation outlines. One by one, I will start. Trade surplus contributes incredibly towards the growth and development of an economy, and higher export indicates that there is a high level of goods and services of a country's industrial unit, which leads greater number of employment in the industrial operations. And micro, small and medium enterprises now are known as the backbone of economies in many countries of the world. These small businesses relatively requires low funding, mediocre technological integration, and semi-skilled labor force. And small business ventures are likely to contribute to the developing countries like Bangladesh, India, Sri Lanka, Tanzania, etc., due to their ease of formation and operations. And farms must focus on quality assurance and productivity to ensure competitive advantage in the highly competitive market, and sustainable productivity linked with sophisticated technological integration. So a big amount of investment is needed to accelerate the production system and exporting goods and services crossing the border of a country. So financing access has been playing a crucial role in this connection. The study has been conducted to examine the trends of export contribution by the sector towards Indian economy during 2011 to 2021. And this study analyzed the impact of financial assistance on MSME's export contribution during the period. The research study is empirical and quantitative. Secondary data has been collected to investigate the relationship between loan outstanding and contribution of MSMEs towards export on Indian economy. And data have been collected from Ministry of Finance, Ministry of MSMEs, Reserve Bank of India, World Bank, newspaper, and from the internet also. Additionally, the software, SPSS software, has been used to analyze the data. This is the trends of export contribution by the sector year-wise, and we find that normally it is showing the increasing trends from 2012 to 2016-17, then it becomes, some extent declining. A regression model has been developed to test the impact of MSME's access to finance on the export, where loans and advances received from the financial institutions by the sector, that is loan outstanding, has been considered as the independent variable, and export contribution of the same has been treated as dependent variable. And hypothesis was formulated: there is no significant correlation between access to finance and export contribution of MSMEs in this economy. If we find the regression result, then the model validity, here the dependent variable is export and independent variable is loan outstanding, and the significant level is, the p-value is 0.003. So the model is significant, and by analyzing the adjusted R-square value, we can say that the value of adjusted R-square in our study is 0.657. That is the independent variable explaining near about 66% of dependent variable. And the correlation result shows that there is a correlation between the exports and loan outstanding, and the correlation is 0.83, 83%, and it is near to 1. So the correlation is there. The export and loan outstanding is highly correlated to each other. MSME sector has been playing an important role in total export of India, and Indian MSMEs have been contributing on average 47% of the country's total export. And access to finance is one of the most significant factors affecting the export contribution of the sector. That is already proven in the hypothesis testing, and private, public, and scheduled commercial banks, foreign banks, and non-banking financial institutions have been providing financial services to the MSME sector very significantly. And this study has been analyzed the correlation between export contribution and loan outstanding during the period, and regression results reveals that export contribution significantly depended on loan outstanding, and the financial institutions should disburse the loan with lower interest rate, affordable collateral, and favorable grace period. Sometimes we found that the small businesses face difficulties in getting loan from the financial institutions, and time taken between the loan application and loan disbursement should be shortened to maintain the credible growth of the sector. It can be concluded that favorable institutional financing can enhance the growth pace of the production and marketing strategies, which leads sustainable export growth of the sector. Future scope for future research. The study has been conducted by limiting the time 2011 to 2021. Further, the data have been collected from secondary sources related to the Indian economy. So future research can be conducted using wide range of time duration and considering more factors affecting the export contribution by the sector. This study has been conducted focusing on only Indian economy. Future investigation concerning other developing countries like Bangladesh, China, Malaysia, and other least developed economies such as Nepal, Bhutan may generate better result in this regard. So that's all from my side. Thank you.
Thank you, Mr. Muhtar Hussain. As you have mentioned about the MSME,
yes, sir.
We are quite everyone aware about that. This micro, small, and medium industries are going to really increase the market input. And yes, obviously, to encourage them, the marketing strategies are required to be designed or developed.
Yes,
I
yes.
have one just one query here. People, those who, it is okay. Those who are recognized micro, small, and medium industries, those who are recognized by the government, those are being monitored. They are being marketed, or they have given their platforms, respective
Yes, sir.
platforms. But there are many people, those who are running such businesses of micro and small and medium levels,
Yes, sir.
but not being monitored or recognized by the industry, by the government. So in that, isn't it necessary? There should be some framework where the government should also look or
Yes, yes,
do the marketing for those people
yes,
also,
sir. Yes, sir.
who are
And
running their personal businesses of these levels.
yes, sir. Yes, sir. And government already, Indian government has taken some, steps also. They have
Mhm.
some packages. They have some, and under the monitoring of, under Ministry of MSME, there is a ministry also.
Because Hussain sir, what I found myself,
Yes,
that
sir.
MSM is only marketing, or they are giving the platforms, because they have taken the loan, the people, those who have taken the government loans, and they are now doing the businesses as per the government guidelines. That is okay.
Yes, 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 yes.
But there are
Sometimes.
many people, those who do not wish to take those loans, and they have their own capitals, and they want to use it to develop such businesses.
Yes, yes.
And somewhere I feel that uh, if they are not even taking the loans, government loans, they should be they should also be given those platforms of marketing, because a common platform for marketing these businesses is really important.
Yes,
And
yes.
the
Of
government
course.
should take that develop such a platform which will be inclusive for all the people, those
For
who are
all
doing
the
such.
people who are not getting benefit from the
Right,
government
right,
also.
right,
Yes,
right.
sir. Yes, sir. It is also needed, because if someone wants to start their business by their own fund, they should encourage also, and they
Right,
should
right,
get some opportunities also, sir. Yes,
right.
we
Thank
should
you, Mr.
focus on
Hussain.
it.
Thank you so much, Mr. Hussain.
Okay, sir. Thank you.
Okay, Anisha, you can conclude now.
Sure, sir. So with that, we have completed all our presentations for the technical session 2B. And I sincerely thank all our authors for their excellent presentation and contribution to the session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this 7th version of the conference and previous 6 versions of the conference. We will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. And the publication will be live within 6 months. So kindly cooperate with the team of ICTIS 2023. I would also like to thank our session chair for their wonderful presence and for chairing the session. And here is a small token of appreciation on behalf of the team ICTIS and Global Knowledge Research Foundation. Thank you so much for your valuable presence, sir.
Thank you, Anisha. Thank you, GR Foundation, for giving this opportunity to chair this session. And it was really delighted to see such a wonderful work from the different disciplines from the different disciplines, including cancer, skin cancer, or maybe we are seeing this MSME presentation, or
Different.
some earlier presentation of secured systems and encryption systems also, or speech related some papers were there. So we could see all that range of work studies that has been research studies that has been conducted by our researchers in this group, in this session. I thank you once again to all of them, and wish them all the success in their future endeavors, research endeavors. Thank you so much. Thank you, Anisha. So
Yeah.
I take your leave now.
Yeah, thank you so much, sir. And now I would request to all the participants to please turn on their cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care. Bye.